Welcome to my new calculus channel. My name is John Gabriel. And today I'm going to discuss one of the least understood books, which is also my favorite book, as you probably all know. And the topic I'm going to discuss is that of construction, okay? And I'm going to reveal some knowledge to you which has never been revealed about this particular topic. So let's begin. Now, you may have noticed often in geometry that there is talk about constructions. And if you actually studied the elements, which most professors of mathematics never study because they think they know what it's all about, you'll notice that the word construction or the word construct never appears anywhere in the original text. So you'll say, but wait, right in front of you it says to construct an equilateral triangle on a given finite straight line. But does it really say that in the Greek? Well, let's read the Greek quickly. It says, επί της δοθήσης ευθείας πεπερασμένης τρίγωνων ισόπλευρων συστήσεσθε. Okay? Now that last word, συστήσεσθε, does not mean construction. Okay? It means introduced. Okay? So it basically says to introduce an equilateral triangle, and with equal, well, and it basically says a triangle with equal sides. All right. So, but what is a triangle? You see, is a triangle just a figure? Well, early on, when there is talk about these so-called constructions, they're not really constructions, because when we see here the description, the actual word used is schema, okay, schema, and that's translated as a figure. But so it says for example here, kyklos esti schema epipedon, okay, and that word schema means figure, but it's actually a distance that is being described, okay? In other words, a particular kind of distance, one in which there are three locations, alpha, beta, gamma, as you see over here, three locations, and the distance between each of the points is exactly the same, and we call this particular distance an equilateral triangle. Okay, so nowhere in the book of Elements is the word construct or construction used. In fact, the Greek word for construction is kataskevy. Okay, and it doesn't mean the same as introduce. If they were the same, then they probably would have been used interchangeably, but nowhere is that done in the Elements, and nowhere is that done in history. So proposition 1, to construct, is entirely wrong. That's false. Now, but you may say, well, isn't it really boiling down to the same thing, because that's what we're really doing with a compass and a straight edge? No, because the constructions are only used to talk about these special distances. You see, geometry is not about figures, it's about distances. All right. You've been misled if you think that geometry is about drawing triangles and octagons and polygons and all that nonsense. Nope, that's not the case. That's not what geometry is about. Geometry is about location and distance. All right. And so when we actually draw these figures, or as purportedly we construct them, we're not actually constructing anything that has meaning without the concept of distance, because we're using these constructions to talk about these special distances and their relationships and their properties and all the peculiarities about them. So when we draw a figure like this, we're referring to this special distance, this A, B, C, right? Or alpha, beta, gamma. And we're showing how it's possible to have that distance by considering the two circles, all right? So in other words, if you didn't believe that you could have such a distance, then you can construct it by the distances, which are these circles, all right? And in the previous definitions, it gives you the basic distances. The basic distances are the line, the circle, and then it introduces the plane, and finally the triangle, and rectilinear figures, etc. Okay, so the Book of Elements starts off not with constructions, but with the essential and foundational properties of distances. In particular, the shortest distances. Okay, so all geometric objects that you learn about are actually referring to special kinds of distances. And you may have triangles that are not equilateral, but in that case, they don't have the same property as the equilateral distance. Okay, so it would probably be more accurate to talk about equilateral distance, right? But constructions are really just used to make the communication of these ideas easier. But you cannot construct a distance. Did you get that? There's no way you can construct a distance. What does that mean? Distance is not constructible, right? You do not construct distance. You construct things or objects or a building. But distance is intangible. It's a concept, okay? And when we talk about constructions in mathematics, it's very important to remember that we're talking about distances and their special properties, because that's what geometry is all about. Well, I hope I've enlightened you a little bit with this new knowledge, and also help you to understand that there are no axioms or postulates in mathematics, because beliefs have no place in sound knowledge or sound mathematics. And the elements do not contain axioms or postulates. Everything can be derived systematically. So I'm not going to continue to ramble on and on and on. I think you've got the message now. Please become a subscriber if you're not already a subscriber, and download my free ebook, which is the most important mathematics book ever written. It also contains a description of the new calculus. And click like so that more people can see and learn about this new knowledge, which has never been shared or introduced to the world before this particular time. So that's all I have to say. My name is John Gabriel. This is the New Calculus channel. Till next time, goodbye.